So we will see here how to find inverse Laplace transform of this function. Now what we can see here, in the denominator we have terms in product. S plus 3 with a linear power, S minus 4 is a repeated factor twice. So now we apply the rule of partial fraction, which gives us 3s plus 2 over s plus 3 s minus 4 to the power 2. Now by using the rule of partial fraction, for linear factor s power 3 s plus 3, we write a divide s plus 3 plus. Now this linear factor s minus 4 repeated twice, so we will be having two terms corresponding to it, s minus 4 power 1 and then another constant c divide s minus 4 power 2. Okay, this is the first step of the partial fraction. Now we need to simplify this. So first of all we should get the LCM. So here the LCM will not be just multiplication of s plus 3, s minus 4 and s minus 4 power 4 power 2. It will be s plus 3, s minus 4 power 2. It should comes from the question, because in the equation we have 3s plus 2 and s plus 3 s minus 4 power 2. On the other hand, if we multiply them, it will give you power 3, which is wrong. Okay, so now we will look for the terms to be multiplied with a, b and c. So as I explained last time, to do that what we will do, we multiply this entire term with the denominator, s plus 3 s minus 4 power 2. So see, when we multiply this with a, I am doing that calculation here, this a over s plus 3. When this is multiplied with s plus 3 s minus 4 power 2, what will happen? S plus 3 cancel, you left with s minus 4 power 2. So with a you will get s minus 4 to the power 2. If you are able to do this thing directly, it's fine, you can do that. But don't do the mistake. Similarly for b, if we check s plus 3 s minus 4 power 2, then this is s minus 4 and this power cancel, you left with 1. So it is s plus 3 s minus 4. Okay, so let me just write it again with some space. S plus 3 s minus 4. And then you are looking for a term with c. So following the same thing, if we do with c, c over s minus 4 power 2 multiplied with s plus 3 s minus 4 power 2. These two cancel. So we left with s plus 3, which is with c. Now what is next step? We compare the numerators as denominators are same. These denominators on both sides are same, so it means the numerators should be same. So we get 3s plus 2 is equal a times s minus 4 power 2, b times s plus 3 s minus 4 and c times s plus 3. Then now here we have to find the values of a, b and c. Three constant. It means we should substitute three different values of s. So as I explained before, we get these values from the denominator. One of the value, by substituting s plus 3 equal to 0. This gives you s is equal to minus 3. Okay, so let's see what will happen here. So we are going to replace s here, here, here and here, and with c by minus 3. So this will give you 3 times minus 3 plus 2 is equal to a times minus 3 minus 4 power 2, b times minus 3 plus 3 minus 3 minus 4 plus c times minus 3 plus 3. So what we can see, minus 3 plus 3 becomes 0. So this total term cancel. Here again with minus 3 plus 3 becomes 0. Total term get cancelled. So what we left with here, if we solve, minus 9 plus 2. This is a times minus 7 power 2. So minus 9 plus 2 gives you minus 7. Minus 7 power 2 gives you 49, which gives you value of a as minus 7 over 49. And it is possible to cancel. So we get a as minus 1 over 7. Okay. Now we work for the second value of s that we get from here. S minus 4 equals 0, which will give you s is equal to 4. So again replace this value of s in this equation. We will get 3 times 4 plus 2 equal a times 4 minus 4 power 2 plus b times 4 plus 3, 4 minus 4 plus c times 4 plus 3. Again cancelling that term which is becoming 0. This becomes 0. This becomes 0 because of 4 minus 4. So what we left with, 4 times 3 12 plus 2 equal 4 plus 3 7 times c. 14 is equal to 7c, which gives you a is equal to 14 over 7. That is a is equal to 2. Here it's c, so here it should be c, not a. Okay, so this is the value of c. We already have value of a in the above step. Now, to get the value of third constant b, we need to get value of, select another value of s. Now, if we look at the denominator gives you s minus 4 power 2 equal to 0, which means s minus 4 is 0, which is giving you s is equal to 4. Again, we have already used this value here. So in this case, when you are not getting the value from the question, here select any value of s on your own. So to keep it easier, start with 0 if it is not used before. Suppose s equal to 0 is already used, then you can go for 1. If 1 is already used, go for minus 1 in this way. But again I am repeating, if you select any other value of s, you will get the same solution. So let's use s is equal to 0 in this equation again. This gives you 3 times 0 plus 2 equal a times 0 minus 4 power 2, b times 0 plus 3, 0 minus 4, c times 0 plus 3. So 3 times 0 becomes 0. Here you left with just 2 on the left side. It is equal. Minus 4 power 2 gives you 16 times a. Now 0 plus 3 gives you 3. This gives you minus 4. 3 times minus 4 gives you minus 12 times b, and 0 plus 3 is 3 times c. Now we have the value of c from the above relation, also the value of a from here. Substitute these values here. So what we will get, 2 equal 16 times, what is the value of a? Minus 1 over 7 minus 12b plus 3, the value of c is 2. When you simplify this, what you will get? Minus 16 over 7 minus 12b plus 6 is equal to 2. Now I want the value of b. So what we will do? We will change the position of these two terms. So this will give us, when this minus 12 goes to the other side, it gives you 12b equal minus 16 over 7 plus 6. This 2 comes on the other side, gives you minus 2. Now here at this stage you can use calculator to get the value, or you can work like this, like I am doing. It's up to you. So minus 16 plus 28 over 7. It's just the simplification. This gives you 12 over 7. So this gives you the value of b as 1 over 7. Okay. So we got from this calculation b as 1 divide 7. Okay. So generally this will happen. The value of a and b differs by sign only. If one is positive, other should be negative. Now we substitute these values of a, b and c in the very first place where we introduced a, b and c. Okay. Remember that this green term is not there. It is just for the calculation purpose. So better if I will remove this thing here, because that is for the explanation purpose only. Okay, to avoid any confusion. So first let me write down what do we have. A is minus 1 over 7, B is plus 1 over 7 and C is 2, right? Yes. So let's substitute these values. This will give us 3s plus 2 over s plus 3 s minus 4 power 2 is equal to a divide a is minus 1 over 7 divide s plus 3 plus b 1 over 7 divide s minus 4 plus c, that is 2 divide s minus 4 power 2. Okay, now taking the inverse Laplace transform of both sides, Laplace inverse of both sides, what we will get? Laplace inverse of 3s plus 2 over s plus 3 s minus 4 power 2 is equal to, minus 1 over 7 is a constant, we can take it outside, 1 over s plus 3 plus, again 1 over 7 is a constant, take it outside, Laplace inverse of 1 over s minus 4 and plus 2 Laplace inverse of 1 over s minus 4 power 2. So when we find the inverse Laplace, this is e power minus 3t. This gives you e power 4t, and for this term, as you don't have the direct rule, you have to use second shifting property here, which is like, you have rule when it is 1 over s power 2, right? For 1 over s minus 4 you don't have the rule. So we can write it as this, where s goes to s minus 4. This gives you t, this gives you e power 4t. Let's complete this one. So this will give you the complete answer as minus 1 over 7. For the first term it is e power minus 3t plus 1 over 7. For the second term e power 4t and plus 2 for this term t e power 4t. So this is your